How much did you pay for your first 3D printer? Maybe like $1,000, $700, $300, or maybe even lower? Well, the reason you were able to pay so little is because of, either directly or indirectly, this machine right here and the work of Adrian Bowyer and Ed Sells. So in today's video, we'll cover what the hell this 3D printer even is, why it's the most significant or important one that I'll probably ever make, how I designed and built it, how you could build one for yourself, how it raised over £2,500 for charity, and of course, a couple of little secrets that you might not have realised without me telling you. So, let's get started. Before we get started, I want to give a big thanks to the project sponsors, which are Big Tree Tech, LDO Motors, E3D, RapRig, and Prushman. Without them, the whole project simply wouldn't have been possible at all, so thank you so much for all your support, it's really much appreciated. To find out more, check out their links in the video description. So first things first, what is this 3D printer? Well, it's called Darwin Evo, and it's based on the original Darwin from 2007, designed, as I said, by Adrian Bowyer and Ed Sells. This 2023 version, designed by me, is obviously designed to look almost exactly the same as the original, but with all upgraded electronics and design features that you might expect in 2023. In order to understand the significance and importance of the machine, we have to go all the way back to square one to understand how this 3D printer basically kick-started all of DIY and hobbyist 3D printing. The RepRap project was a research project at Bath University, where the idea was to create a mostly 3D printed 3D printer. So it's a self-replicating rapid prototype machine, which is kind of what 3D printing was known for, its rapid prototype capabilities. The outcome of that project was Darwin 1. So why has this printer had such a massive effect on the price of your printer? Well, prior to RepRap existing, if you wanted to buy a 3D printer, you were spending pretty much mega bucks. They were for big businesses to do their prototyping very, very fast compared to traditional methods. It was a huge advantage to many industries and thus demanded ridiculous pricing. Here comes RepRap, and suddenly not only can you print a majority of the parts to make another printer, but all the parts that are not 3D printed are easily accessible from hardware stores or just shops online. So suddenly you're down into the hundreds or maybe a few thousand as opposed to the tens or hundreds of thousands. The significance of this printer this year was of course the Sanjay Mortimer RepRap Festival in the UK. Unfortunately, Sanjay passed away 2 years ago, and he was one of the founders of E3D, a very significant and important part of developing from the very start of 3D printing into what we have today. Of course, you will probably know E3D now for their innovation and developments in hot ends and extruders. Upon his passing, the Sanjay Mortimer Foundation was set up, a foundation whose prime objective is to seek out and assist those with neurodivergence to help them realize their potential in engineering. So since the Sanjay Mortimer RepRap Festival was the first RepRap Festival in the UK, and the UK is where RepRap started, what better printer to represent the start of RepRap in the UK than Darwin. Now, not only was this kind of printed just there for the show and interesting for people to come and kind of look at and experience, I got to talk to a lot of lovely people about this machine, which was very nice. It was also auctioned off for charity, and it went for £2,650. So all of that money will go to the Sanjay Mortimer Foundation, which we've already discussed their purpose. Now that you know a little bit more about the machine and why it exists, let's go into how it all came together. The project started with 3 objectives. First, it had to look like the original 2007 Darwin. Secondly, it had to use all modern electronics and designs and design principles from current open source machines. And thirdly, it had to look cool because it was going to be auctioned off for charity. I won't be able to share all the details of the design process here. It's just an enormous task which I'm shortening down into the key points for this video. So there's going to be a link down below to a blog on my website, which will have a little bit more detail on that process and how I did it, and some of the things which we don't have time to share here. The main goal initially was just kind of feasibility and working out what are the things that I might need to change, what can we not really get hold of nowadays, what kind of new and easily available stuff should I be putting into it. This right here is what the original CAD looks like. I downloaded it, I think, from just the RepRap.org website. It's all just there available as step files, and I've pulled it all together in Fusion 360, and this is what we have. So I took that entire existing CAD and started just pushing and pulling parts, putting in new holes, deleting some things, adding in some things, dropping in motors and basic shapes here and there, just to give me a better picture in CAD of what I might be targeting. And then once I'd done all that, I actually basically removed all of that work that was kind of sitting in a background as a reference and started the whole thing from scratch, piece by piece, building up the entire thing from nothing. So yes, although it looks like the original Darwin, in fact, everything is new. Going in a rough sort of assembly order, we'll start with the kind of core frame and the 3D printed parts that go into that. The main part is these Swiss cheese blocks, as I'm calling them. It's the kind of QB sort of parts, which just have loads and loads of holes in. These are quite different from the original, as the original I think used some embedded M8 nuts like in the middle of the print, and then threaded M8 rods to put the whole thing together, although I couldn't quite see how that mechanism worked in the CAD. So what I've done, I've used hardened smooth rods with some heatset inserts and grub screws. This is really good because it means the rods slide really smoothly when the grub screw's not inserted, but as soon as you tighten it in, it's locked really tight and doesn't move a bit. So that works really, really well, and it makes it a little bit easier to assemble, probably, than the original. After we've got the main frame pieces assembled, we move on to the Z-axis assembly. Originally, this was M8 threaded rod, as you might expect, but nowadays, lead screws are way cheaper than they used to be. The original also used a NEMA 23 motor, but in a slightly weird configuration. Instead of being kind of face up with the shaft poking out the top, as you might expect, it was face down and the shaft poked out the back. Now, that was not particularly convenient for me to source, and I think if others were going to try and build this machine, that might be difficult for them too. So what I've used is the Z motor and kind of entire Z design from the RatRig VCol 3.1. So it includes the standard Z motor from that printer, as well as the thrust bearing, which holds the load, the coupler, the lead screw, the Oldham coupler at the kind of in the middle on the lead screw, and the bearing at the top. Now you might be wondering why we've got a belt if we've got 4 Z motors. Well, here's your little secret, which you might not have known otherwise. The belt doesn't do anything. As the printer is printing and it's doing things like Z-top, because all those lead screws rotate together, it actually still moves the belt and it looks like it does something. But it also means, because they're independent, we can do a kind of opposite of a quad gantry level, which you would see on a Voron 2.4, but of course here it's leveling the bed. After we've got the frame and Z-axis stuff together, we move on to these kind of cross brace. So these are what make the overall frame really, really stiff, and they do work really well. I've made 2 main changes here, one being grub screws, so where they hold onto the smooth rods, we're using grub screws to hold them tightly, and that works really nicely. And the second thing is these blocks in the middle, which have 2 purposes. Firstly, they stop any rattling between the threaded rods as they're very close together, and because we can print quite quickly with some quite high vibration, we don't want them banging against each other. The second thing they do is provide some mounting point to stop rotation. Mounting to threaded rod is not that easy if you don't want things to rotate around it, so we're using this piece in the middle to provide a kind of solid platform for adding things. You'll see later we've got things like DIN rails for mounting electronics. Next we move on to the bed assembly, which is quite different to the original. The original was basically just a big piece of MDF all the way across. There was no heating or anything, so that was your print surface. I think stuff was like attached to it, like paper or masking tape and stuff like that, but obviously we've moved a little bit on since then. So what we've got here is a Voron 2.4 300mm bed. It's a mains powered heated aluminium bed. It could go up to like 100, 110 degrees Celsius for like your Voron design stuff. However, in an open printer like this, like 60 to 80 is going to be fine for your PLAs and your PETGs. The other part of the bed assembly is like the mounting platform, and that's the piece that I've made out of wood. Plywood is still kind of an engineering material, so it's still plenty sturdy enough for the job. You just don't want to make it obviously too hot, but I think we're fine here. There's a big gaping hole in the middle, so most of the heat can escape. Next up we have the Y-axis, which is the bit on top which moves everything kind of forwards and backwards. Originally this was a single NEMA 23 with rods at the front and rear to transfer that motion over to the other side, so we had belts on both sides. I decided to change that up a little bit, so instead of having the rod at the front, I've changed it to 2 motors, and these are both NEMA 17 instead of NEMA 23. Again, just a bit easier to source, especially given it's basically a Voron 2.4 motor kit. We still have the shaft at the back, so those 2 motors are coupled together, although they don't necessarily need to be, but it was part of trying to keep some of the original design in there. Next we move on to the X gantry, which is what we're calling the bit that moves forwards and backwards rather than the bit that does the moving, which is the Y-axis. So the X has not too many changes. Of course, again, we've changed a NEMA 23 motor into a NEMA 17 motor. Originally, this X idler end was very different to the other design and cut off some of the printing space. So I kind of flipped it around, copied the other side, added an idler, and it looks all very similar to the motor end, but it's very different to the original. Another upgrade on the Y-axis is the bearings. Well, I say upgrade, I don't really know exactly what the original was. So I've used in many places the LM8 LUU. Next we move on to the X carriage, which is the part that moves left and right, but excluding the hot end and extruder, which we'll talk about in a minute. This has changed quite a lot from the original design, although it kind of keeps some of the fundamentals. We've gone with the 3 bearing layout, so 2 on one side, 1 on the other, although I think in the original they were like the reverse way round. It had 1 at the front and 2 at the rear, and the hot end would secure on one side, but it was very difficult to kind of replicate this design with stuff that was modern and kind of perform well. So a lot of the old carriage design is sort of just gone completely out the window, and I've created this new one. One of the difficult aspects of getting this just right was making sure that those bearings roll very smoothly on completely 3D printed parts. Because even though you don't get much warping, there's still a little bit, and with these bushings, any small amount of misalignment will create a lot of friction in the motion. The way I got around it is by having kind of bearing stacks with these kind of cages, and then very small shims of tape to try and realign the bearings as needed. It feels like a little bit janky, but it works really, really well, and I'm really happy with how it's turned out. Of course, attached to the carriage, we have this big hot end and extruder assembly. Now, you might think that I've designed all of that from scratch, but I absolutely have not. If you're familiar with the Voron Design 3D printers, you may be thinking that it looks a little bit like what they have. So this is in fact a Stealth Burner and Clockwork 2. Clockwork 2 being the extruder design and Stealth Burner being the hot end and airflow design. That is what you see up there. I've just kind of blockified it into a 2007 RepRap style instead of the modern angled low poly Voron design. One of the big reasons for going for this design of hot end and extruder is that I didn't want to be redesigning stuff completely from scratch. It would have been quite disappointing to do all of this work, get to a show and start printing, and the prints just come out kind of mushy and because of like poor airflow and stuff like that, or getting like hot end jams and all these things. I wanted a reliable hot end and extruder design that I knew would work, had decent cooling and was just ready to go. For the hot end, of course, we had to go with E3D. We've got the Revo Voron with a Revo 0.4mm obsidian nozzle and a 60-watt heater, as well as these big banks of high flow nozzles and stuff across the front for some extra bling. For the Z-axis and mesh bed leveling, I've integrated a Prusa style Pinder probe sort of thing. I'm not sure if it's exactly the Prusa one, but it's basically very similar, and that works really well, especially on these open type 3D printers. Now that we've got all the mechanical stuff kind of mostly out of the way, we can move on to the electronics. The main control board is the Octopus Max EZ. This control board can have up to 10 stepper drivers, of which a bunch of them can also have sensorless homing, which I've enabled for our X and Y axis. All these stepper drivers are TMC 22.9 on the Big Tree Tech EZ format, which is the kind of vertical slotting in ones. Since we're running Clipper, we also have a single board computer, and of course I went with the Raspberry Pi 4. To power the Raspberry Pi, I've used ElectroPi, which is a prototype Vector 3D product, which is a 5 volt, 5 amp power supply that takes 24 volts, powers the Pi, and provides 5 volts auxiliary for other stuff, and it has a cooling fan, so that's really good too. For the screen, we have the Big Tree Tech HDMI 7, which is a 7-inch HDMI touchscreen. We also have the Big Tree Tech Smart Filament Sensor 2.0, which detects both filament presence and filament motion. We also, on the toolhead, have the Big Tree Tech Nomi, which I mentioned before. I've customized this to be a green theme and replaced the Voron logo with a RepRap logo. For the toolhead, we have the Bigtree Tech SB EB2209 RP2040. It's quite a complicated name, but basically it's a CAN toolhead which uses a TMC 2209 stepper driver for the E-motor and uses an RP2040 as the MCU. That connects via CAN bus, so only 4 wires, back to the U2C, which is a USB to CAN bus converter, and then that goes back to the Raspberry Pi. I think that covers most of the electronics. Of course, the firmware we're running is Clipper. Personally, I find it really simple to configure and still very advanced. You can do a lot with it. It's also running the Mainsail web interface, which I find really useful for controlling the printer, especially when you're doing it from another room. When it comes to wiring and other accessories and stuff, the original Darwin didn't really have a lot of these for like reasons that they didn't exist, but I've added a bunch of them here. So we've got a spool holder for the filament. As I mentioned, the smart filament sensor for detecting that. We have a drag chain for the X-axis wire. Maybe a little bit overkill, but it works nicely. All the electronics are DIN rail mounted with little clips and stuff, so easy to mount and unmount if you need to. All the power supply and stuff is all mounted into the machine, and everything up to like here is all earth. So it's all like connected with earth straps to make sure it's as safe as it can be in the event that maybe like bed wires or something come loose. Very unlikely, I think, to ever be a problem, but that's kind of what earth wiring is for. Of course, all the filament used here is Prussiament. So for the main kind of white-ish part, it's an off-white. It's the ASA natural color. And I think that's turned out really, really well. You can actually hardly see the layer lines on it. So really nice filament. There's also the green accents. Those are PETG because I needed the color to match the RepRap logo as close as possible. And that was the best filament to do so. Again, it's Prussiament stuff. So now that you know how I built it, how can you build it? Well, this is all open source. Well, at least the original was, so I'm going to do my best to replicate as much of that open source information as I can. Obviously, the electronics and stuff by other companies, I can't control any of that. But for all the design files that I've done, all of those files I think we'll make available on printables. Wherever it ends up will be linked down below, and you can find everything you need there. Hopefully, as much as I can. It's a lot of work, but I'll do my best to make it organized and simple for you to print out the parts, buy the things you need, and get a working printer. I'll do the firmware and stuff there too, so fingers crossed you can get everything you need. One of the things I haven't really mentioned in this video up to this point is why this machine is significant for me as well as for 3D printing. So for those that don't know, I was diagnosed with bowel cancer in the middle of this year and had to have surgery to remove it, and that was quite an extensive process. It didn't go that well, so my recovery phase after surgery has been extensive. It took a lot of time of me not being able to do very much, so it was really nice to be able to just kind of quietly and slowly get on with this and work on it in the background. In a weird kind of way, I wonder if I wouldn't have been able to finish it if it hadn't been for having that recovery phase where I could dedicate that time to doing it. It's a little bit of an odd one. It feels like something nice has come out of a rather shitty situation. So hopefully lots of people can get enjoyment from this machine, as well as how much it helped me through that difficult part of my life. I've had a lot of questions from people on how fast can it print and what are the accelerations and flow rates and stuff like that. And honestly, I don't really think it's about that at all. So I'm not going to test it. I'm just not. Because this is a historically significant printer, it can print. I had it printing all the way through the show, and if anything, it was one of the most reliable printers at the show because it printed from the beginning of day 1 to the end of day 2 without hesitation. So there's that. A lot of printing these days, everyone's just aiming for maximum performance and 20, 30k acceleration, and I do this flow rate and that. I don't really care for this machine. It's not about that. It's about enjoying the printer, enjoying the build, enjoying the significance, and having some fun. And it definitely ticks all of those boxes. And of course, we raised lots of money for charity in the meantime. So for me, this build has absolutely been a success, and hopefully you can get some success out of building one as well. Links are down below. While I was editing the video today, we've got confirmation of some amazing news. I'm going to be building one of these for Joe Prusa. That's right, the one and only Joe Prusa of Prusa Research. So That's going to be happening in the new year, and we're going to be getting another donation of the same amount to the Sanjay Mortimer Foundation. So that is excellent news. You might also be interested to know that we are also looking into kits. So if you want to have one of these, but are not particularly keen on sourcing all of the parts from loads of different places, it can be quite a complex process. Hopefully we'll be seeing some kits sometime in the new year, although it may take some time because they're quite complicated to arrange. I do want to give one more thank you to the sponsors as well, Big Tree Tech, LDO Motors, E3D, RepRap and Prusherman, because without them, none of this would have been possible. So thank you very much. And also a little thank you to Voron Design, because quite a bit of this printer is inspired by particularly the Voron 2.4. So thank you for doing what you do. So that's it from me and the Darwin Evo. I wish you a Merry Christmas, a jolly holiday, a Happy New Year, and I'll see you in 2024.